Welcome to EPG Pathshala. Today we will be talking about antennas. As we know, antennas are the devices which are used to transmit and receive the signal. So, antenna is we can say in this module we will talk about what are the characteristics of an antenna, what are the different classifications of an antenna, what types of antenna exist, and what are the application areas of those antennas. And at the end we will conclude with the summary of that antenna. So, now we will start with our introduction part. So, now we discuss what is an antenna. So, antenna is a metallic device which is used to send and receive signals. So, if you can see here, an antenna is a metallic device which is used for transmitting and receiving the radio waves. Basically, it has a transitional structure between the free space and guiding device. The guiding device may take the form of coaxial line which transport electromagnetic energy from the transmitting source to the antenna or from antenna to receiver. So, the main job of antenna is to transmit the radio waves in the space, and there is some guiding devices which are available in the space. So, if you can see here, these are the antenna. If you see on the picture, you can see the antenna which we are very familiar with. Earlier we were using at the top of the building these type of antennas, and these antenna working in a particular direction. So, if you move the antenna, then you receive the signal. If there is some deviation in the antenna, then you are not getting the signal. So, if you have seen number of times in number of movies also that they are moving the antenna, then they are getting the signal, then the signal is catch and then it is projected on your TV screen. So, they are basically based on the directions. So, if the direction is there and it is able to receive the signal, then only you can see whatever transmission is taking place in that particular direction. The same thing is happening here, even on the vehicles, on the car, on the other devices, you can see the antenna for catching the waves. So, that particular, if we are listening the FMs and all, radio and anything, so what is happening, they are projecting on a certain frequency, and our antenna is basically catching. If we set the frequency, our antenna will catch the waves of that frequency, and then we are able to listening the audio. So, in that case also antenna is in, we can say in the normal day to day life, the movement of radio waves is basically affecting our lives. So, if I want to listen a radio and see any picture, any movie, so I have to project my antenna in a particular direction. So, antenna plays a very important role in our lives. Now, we talk about the characteristics of the antenna. So, if we talk about the characteristics, it starts with the size and shape. So, now we can see there are antennas of different sizes and different shapes. Basically, size and shape will affect the efficiency of any antenna, and it depends upon frequency at which transmission and reception is taking place, and also the direction of the radiated electromagnetic wave. So, antenna size and shape always affect how the energy is radiating and how you are getting it. The size of the antenna is inversely proportional to the wavelength signal to which it is designed to transmit and receive. Lower signal require large antenna and larger signal require small antennas. So, the size and shape always affect the efficiency of the antenna. Now, the second characteristic is the radiation pattern. If we talk about the radiation pattern, it is basically a mathematical function which graphically describes that the radiation property with respect to the space coordinates. And now we talk about the third one, that is the radiation power density. Basically, power has been associated with each and every wave which is moving in the space. So, electromagnetic waves are used to transport information from one point to another point, and the power intensity decide the distance covered by the EM wave. Now, if we talk about the fourth characteristics, that is the radiation intensity. As the name suggests, intensity, how intense it is. So, basically it is defined as the power radiated from an antenna per unit solid angle. So it is basically the multiplication of this radiation density with the square of the distance. So how much distance that radiation is covering, square of that multiply with the radiation power density, that will give us the radiation intensity. Now we talk about the fifth, that is beam width. You see, beam width is basically the angular distance between two opposite side points which are identical in nature. So that particular angular distance is called beam width. The next characteristics is directivity. Now basically what is the directivity is for direction. So direction in which the waves are moving. So now it is basically the ratio. If I talk about the directivity, it is the ratio of the intensity in a particular direction, radiation intensity in a particular direction to the radiation intensity overall in all the directions. So in a particular direction divided by in all the direction will give me the directivity. Now we talk about the next property, that is called efficiency. How efficiently your radio waves or electromagnetic waves are moving in the space, that is defined with the help of these characteristics, that is called efficiency. Now the efficiency of antenna is defined as the ratio of power radiated to the total input power supplied to an antenna. So how much power is supplied to antenna is inversely proportional to the efficiency, we can say. Now the next property is called gain, or the characteristic is called gain. So gain is basically the ratio of maximum radiation intensity in a given direction to the maximum radiation intensity from a reference antenna produced in the same direction with the same power input. So that is basically called the gain, that how much maximum radiation which we can get in that particular direction with reference to the antenna produce the same direction with the same power input. Now we talk about the last characteristics, that is polarization. Basically the polarization is the orientation of E and H waves transmitted or received by the antenna. So polarization is basically giving the orientation. What is the orientation of a particular wave in a particular direction? So if we talk about the characteristics, these are some of the characteristics on the basis of which the antenna is working. We can find out the efficiency, we can find out the gain, we can find out the radiation pattern, we can find out the power intensity. All these are basically the most of them are the mathematical equation which tells us how the signals are transmitting from the transmitter, transmitting or receiving. Both work is done by the antenna. Now in the next slide we will be talking about the classification of an antenna. Basically when we talk about classification, there are certain bases of classification. So in antenna also there are certain 4 basic differentiation we have done for the classification. The first is, as you can see on the slide, that is the radiation. The second is frequency. On the basis of frequency we can classify. One is aperture, one is polarization. So if we talk about the radiation, on the basis of radiation there are some these type: isotropic, omnidirectional, directional, hemispherical. All these antennas are part of, on the basis of radiation these types are possible. On the basis of frequency there are cone antennas, there are fan dipole antennas, there are pyramidal horn antennas, there are fractal antennas. These are the antenna which are made on the basis of frequency. Now if we talk about the aperture, then there are wire antenna, horn antenna, parabolic antenna, microstrip patch antenna. These are on the basis of aperture. And polarization, that is orientation. Based on orientation there may be vertical antennas, there can be horizontal antenna. We can say vertical polarization antenna, horizontal polarization antenna, and the third category is the circular polarization antenna. So there are basically 4 characteristics on which the antennas are classified. One is radiation, one is frequency, one is aperture, and the fourth is polarization. And under these each and every category we are having some other subcategories of the antenna or subtypes of antenna. So based on our usage we can define which type of antenna we want and what are the our main, whether on the basis of radiation we want to use some antenna, on the basis of frequency we want to use some antenna, and based on aperture or based on orientation, that is based on polarization if you want to use certain antenna. So now we based on radiation, now this is the classification 1. So based on radiation there are basically the 4 categories. We start with the isotropic antenna. If we talk about an isotropic antenna, it is a fabricated antenna. It radiates uniformly in all direction. You can see here, this is the antenna and here these are the radiation which are emitted by this antenna. So you can see it is equally transmitting the radiation in all the direction. So it radiates uniformly in all the directions. Now an isotropic antenna is basically a hypothetical lossless antenna. An isotropic antenna is used as a reference antenna with which practical antennas are compared. So isotropic antenna is an antenna which radiate the radiation in all the direction. Now we talk about the second one, that is omnidirectional antenna, which is also an antenna which is based on radiation. So now here you can see that it is transmitting equal intensity signal in all the directions. Here you can see these antenna basically cover equally in all the direction, having an angle in elevation direction, and mostly the wire antenna are having omnidirectional radiation pattern. Here this is the antenna and these are the radiations. So you can say intensity of all the radiation are equal. So basically this is an omnidirectional antenna which is comes under radiation category or based on radiation category. Now this is directional antenna. So what basically here you can see it's a direction. This is the antenna and these are the direction it is covering. In a particular direction it is moving. So they are basically used when signals are required to propagate in only one direction. There are again it is divided into some of the subcategories. One is Yagi antenna, one is parabolic dish antenna, one is patch antenna. Basically if we talk about the Yagi antenna, this is a Yagi antenna. So it emits a wider, lesser focused RF energy beam. So this is a Yagi antenna which is emitting the beam which are less focused, but the area of coverage is higher. Now if we talk about the parabolic dish antenna, emits a narrow, more concentrated energy beam. Here you can see this is parabolic dish antenna which is highly concentrated. You can see these beams are highly concentrated and it is very narrow in nature, while Yagi was transmitting a wider range and less focused, but this is more focused and more narrow and concentrated one. And patch antennas are there which emits a horizontal wider beam but vertically taller. So if we talk about the directional antenna, these are the 3 subcategories of the directional antenna. Whenever we have to emit in a particular direction, we always use the directional antenna. Earlier at our home, top of our home, we were having these directional antennas. Even if we want line of sight, if 2 buildings we want to communicate, earlier times there was 2 antennas put on the one building one, second building another one, and then they are on the line of sight, there are particular direction and in which transmission and reception was taking place. So that were the example of the directional antenna. Now there is the second one or the second classification which is there on the basis of frequency. If we talk about the basis of frequency, there are different type of frequency antennas which are available. Already I have said that the FM radios we are having, that is basically frequency based antennas which are if we are changing the channel from 98.3 to 96.7 or 95.0, so that is basically working on a particular frequency. So frequency are categorized in some of the subcategories like very low frequency and low frequency antennas we are having, medium frequency antennas we can have, then high frequency antennas, very high frequency antennas and ultra high frequency antennas, super high frequency and extremely high frequency antennas. So on the basis of frequency there are different antennas which already I have shown you, that cone antennas are working on the base of frequency, the fan dipole antennas are working on the base of frequency, pyramidal horn antennas they are working on the base of frequencies, and fractal antennas they belong to some of the frequencies in this, and they are categorized on the basis of frequencies. So now we can talk about the third classification, that is based on aperture size, that how the aperture is there in which the radiations are moving from that aperture. So based on aperture there is another sub classification has been done. So now I talk about the first one, that is the wire antenna. So basically here you can see the three images. If we talk about this particular image, this is called wire dipole. Dipole here is, you can see 1 and 2. So 2 directions are there. Here this is 2 and your radiations are moving from here. So this is basically called wire dipole antenna. This particular image is basically the monopole antenna. Here you can see only one orientation. So this is the monopole antenna. And if you talk about this is also an aperture based antenna which comes under the wire antenna. This is called a loop. This particular is called a loop. So loop antenna are like this, loop wire antennas are like this. So these type of antennas are seen at the aircraft, building, car, etc. They are of different sizes and shapes, as I told you, that here this is wire dipole, this is wire monopole, and this is called loop. So mainly in the aircraft and buildings we are using aperture based antenna, and aperture based also the specified antenna are called wire antennas. So now we move to the second aperture based antenna, that is horn antenna. If you see here on the screen, these two are basically, there are more categories of the horn antennas, but this is called E-plane antenna, E-plane horn antenna, and this is called basically conical horn antenna. So horn antenna is basically widely used microwave antenna, different forms, and what is happening here, you have the hollow pipe and the hollow pipe of different cross sections. Here you can say this is E plane and this is canonical plane. So different hollow pipes are there, different cross sections are there, which has been pointed towards a larger opening. Here you can see the opening, here you have this opening, here you have this eclipse like opening. So these are the larger openings, though the pipe is narrow. So this pipe is moving toward the larger opening, and the type, direction and amount of opening will affect what type of this opening, what is the size of this, what is the shape of this, that will affect the overall performance of the horn antenna. Typically there are 4 types of horn antenna, one is E plane, one is H plane, one is pyramidal and conical. So here these two images are, this is E plane and this is conical. Now we talk about the third categories of aperture antennas, that is called parabolic antenna. Here in the image you can see the parabolic antenna. What basically it is a 2-dimensional plane curve and it is having 3-dimensional curved surface, and it basically rotate. This basically the rotate. So it is formed by rotating a parabola about its axis, and the surface is known as paraboloid or microwave dish or parabolic reflector. This is called parabolic reflector, and here the antenna consists of primary antenna situated at the focal point of this. So, here this is basically a dipole or a horn, any of the two. You can use either dipole or a horn, and above that you are having this parabolic reflector, and basically this will, and it is situated on the focal point of this dipole, right. So, this is basically the parabolic antenna. Now, there is the fourth classification, that is microstrip antennas. This is basically a aperture based antenna. What basically the microstrip was doing, it is basically became popular in 1970s. It is very low profile antennas, but the main application is in the spacecraft or aircraft, where size, weight, cost, performance, ease of installation, all constraint exist. So, if we have to work in these constraints, we can go for microstrip antenna, because they are less costly and easy to install on the spacecraft or aircraft. So, based on aperture, we are having basically the 4 categories we have already discussed. One is wire, one is horn, then one is your this parabolic antennas, and then you are having microstrip antennas. Now, after the aperture based, the next category is the polarization, that is the 4th category, because sometime we want antenna to work on the basis of orientation. So, polarization is nothing, is the basis of orientation if we are bifurcating or classifying the different antennas. So, here we can see that based on polarization, the first subcategory is the vertical polarization antenna. Basically, how that polarized vertical polarization antenna works is, here you can see in the figure, this is the antenna, and this is basically the orientation of wave. Now, how the signals are moving, you can see here these are the vertical lines. So, basically what the vertical polarization antennas are doing, they are transmitting vertical electric field, and they are polarized in the vertical direction. So, the orientation is vertical. So, if an antenna is transmitting or receiving vertical electric field vector, then antenna is said to be vertical polarized. Here you can see these vertical lines. So, basically these are vertical polarized beams. Now, the second category under polarization is horizontal polarization antenna. Now, here you can see the orientation of wave differs. This is our antenna and this is orientation of wave. So, now this is horizontal. So, now what is happening, your waves are like this, horizontal. So, all your waves which are radiating in the orientation is horizontal. So, you can see orientation of wave is horizontal. So, if an antenna is transmitting or receiving horizontal electric field vector, then antenna is said to be horizontally polarized antenna. Now, the next category is the circular polarized antenna. When we talk about the circular polarized antenna, that means the orientation of the wave is in the circle, which is neither horizontal nor vertical. It is basically the circular orientation which is taking place. Now, we talk about the third one, that is, now here you can see circular polarization antenna. So, if an antenna is able to transmit or receive E field vectors of any orientation, then antenna is said to be circularly polarized antenna. This is an example of circularly polarized antenna. So, in this your E field vector is of any orientation in this circle. So, basically when we talk about on the basis of polarization, there are 3 categories: horizontal, vertical and circular. So, when we see the orientation of the wave, when it is vertical, the orientation is also vertical. When it is horizontal, the orientation is horizontal, and when it is circular, it is moving in any of the direction. So, this is on the basis of 4 how we have done the different subcategories of the antennas. Now we talk about some of the additional antennas which are exist. That is, the first one is, here you can see the array antenna. Here in here you can see the linear array, circular array, planar array, conformal array. So some of the application we want, in some of the application we want some what we can say, summation of all the waves, rather than singly it is done, we want the aggregation of all. So if we want the aggregation of all, we can use array, and that is a main job of the array antenna is that the radiation power has been increasing by the addition. So here is some application require aggregation of radiation, their requirement does not be met by one radiator. So they will make certain arrangement like this, and then they add up all the radiation and get the maximum radiation. Here this is linear, this is circular, this is planar, and this is conformal. Now another additional antenna is reflector. So this here you can see is the reflector. What basically it is doing, when the communication is required in great distances, sophisticated antennas are used, which are called basically the reflector, and basically they are made up of the large diameters so that more distance can be covered and the signals can travel miles of the distances using the reflector antennas. There are some other antennas which are called the smart antennas. Smart antennas is basically what they are doing. The smart antennas is, it will increase the capacity and useful receive signal level by lowering the interferences level, means it will remove the interferences which is happening. It will increase the range because they are more directional as compared to omnidirectional or sectorized antennas, and they are more secure because it is difficult to tap a connection in smart antennas, and they can be used for location based services. So nowadays we are using more and more smart antennas. Now next we talk about the applications of the antennas. Here you can see the application of the antennas. Defense services we can use, astronomy we can use, satellite communication we can use, and geographical information system we use antennas, and wireless communication. These are some of the application areas of the antennas. Now at last we come up with the summary of this, that is that antenna, without antenna transmission receiving the signal is very difficult. So antenna is must. Now the field of wireless communication, as we know, it is growing nowadays, and antennas are playing a vital role in that. There are many categories of antenna which we have discussed in this particular module, that they are classified on the basis of radiation, frequency, polarization, aperture, and there are even some additional like reflector, array, and smart antennas. So nowadays we are more and more using smart antennas. So they are different category. Radiation pattern plays an important role in the performance of antenna. Satellite communication is done only with the help of antennas, and the signal transmission across the globe is done with the help of antennas. So in this particular module what we have seen is what is an antenna, how an antenna is basically working, how it is classified in different categories, and how it is used in day to day life, whether it is whatever type of antenna it belongs to. And nowadays we are more going towards the smart antennas. So this is all about this particular module, and thank you for visiting EPG Pathshala. Thank you.